Okay, good day, grade 8s. I trust that you are well. This lesson is merely a revision lesson for test 2, or rather test 1, and we will solely deal with algebraic equations. So let's get into it. So let's start off with algebraic equations. Now, algebraic equations is nothing new. You looked at it in primary school, but you may not have realized that you looked at it in primary school. For example, if I have placeholder plus 1 is equal to 2. The obvious response is that I need to place 1 in the place of placeholder because 1 plus 1 is 2. It's simple as that. But in high school, we don't use placeholder. We use the variable. And a variable is basically a letter that represents a number. And the most commonly used letter in mathematics is x. So instead of saying placeholder plus 1 is equal to 2, I'll just say x plus 1 is equal to 2. And we learned that we can use what we call additive and multiplicative inverses in order to get rid of certain numbers. Because if I ask you to solve for x, the final answer here in your mind should be x is equal to something. So I need to get rid of this 1. And what we need to do is use the additive inverse of 1, which is negative 1. And we add negative 1 to both sides, which is the exact same thing as subtracting 1 from both sides of the equation. Because an equation is a scale. The left-hand side has to be equal to the right-hand side. Or you can think of it as taking this 1 to the other side of the equation, or the other side of the fence. Now, this is not mathematically sound. What we're actually doing is subtracting 1 from both sides of the equation. But you can think of it as taking a number to the other side. So we have 2 minus 1, x is equal to 1, and that is why we have 1 in the place of placeholder. Now, let's look at a couple of examples where we use additive and multiplicative inverses in order to solve for x. Let's take example 1. I have a minus 20 is equal to 10, and I'm required to solve for a. Right? I'm required to solve for a. So to solve for a, what I'm going to do is I need to first get rid of the constant. The constant is negative 20. So I'm going to take negative 20 to the other side of the equation. I'm left with a is equal to 10 plus 20. A is equal to 30. So if I substitute a is equal to 30 into the equation, I will see that my left-hand side, now this is just a check. Your answer ends at a is equal to 30. But if you have some extra time during the test or an exam, you can actually double check to see if your work is correct. And that is why I loved algebra in school, is because you can double check your work as well. So let's look at the left-hand side. The left-hand side is a minus 20. So if I substitute 30 in the place of a, so remember, whenever you make a substitution, you make use of brackets. So it's 30 minus 20 is equal to 10. The left-hand side is equal to 10, and my right-hand side is also equal to 10. So I know that my answer is correct. If the left-hand side is not equal to the right-hand side, then I most likely did something incorrect. Now let's look at more examples. So I'll just flip that page over. Let's look at more examples. Let's say I have something like this. I have 5 plus 2x is equal to 10, and I'm required to solve for x. Now, I'm getting these questions from your revision pack, so you can just take a look at it. This is actually question 2 from the revision pack that I have created for you. So when we solve an equation, right, I can see that there's a 2 as the coefficient of x. The first thing I do, I have to ask myself, do I get rid of the coefficient first or the constant? You always get rid of the constant first. So I'm going to take the constant, which is 5, to the other side of the equation. I'm left with 2x is equal to 10 minus 5. 2x is equal to 5. And now to solve for x, I divide the left-hand side by 2, the right-hand side by 2. And why do I divide both sides by 2? Technically, I'm multiplying the left-hand side by a half and the right-hand side by a half. That's the multiplicative inverse. Well, multiplying by a half is the exact same thing as dividing by 2. And the reason why we divide by 2 is because the coefficient is 2. And 2 divided by 2, any number except for 0, because 0 divided by 0 is undefined, but any other number divided by itself is equal to 1. 2 divided by 2, 2 goes into 2 one time. So I'm left with 1x, or just simply x, is equal to 5 over 2. And it's fine, you can leave your answer as the simplest fraction. Right. And moving on from there, there's a nice interesting question from your revision pack as well that I'm just looking at now. It's 2x plus 5 is equal to 3x plus 7. Now, remember, an algebraic equation is basically defined as an algebraic expression that is equal to another algebraic expression. So this is one algebraic expression. It's a binomial. It's an algebraic expression with two terms that is equal to another algebraic expression, which is um, a binomial, an algebraic expression with two terms as well. So to solve this equation, the goal is to get x, or the variable, whatever you're dealing with, to one side of the equation and the numbers to the other side of the equation. So 2x, usually in my mind, I know that whatever working out I have, my final answer will be x is equal to something. So x should be on the left-hand side of the equation, or of the equal to sign. 2x is perfectly fine on the left-hand side. I do not take it anywhere. So I just drop it down as 2x. 5, it's a number, it's a constant. So I need to take it to the other side of the equation. The goal is to get the numbers to one side of the equation and the variables to the other side of the equation. Now, if I look at the right-hand side of the equation, I can see I have 3x, and by the way, it's positive 3x. So if I take positive 3x to the other side, the sign is going to change. Remember, also with the 5 as well, it's positive 5, I need to take it to the other side, the sign is going to change. That's the rule of taking a number to the other side. But mathematically, what we are doing is that we are subtracting 5 from both sides of the equation. Likewise, we are subtracting 3x from both sides of the equation. We're making use of the additive inverse. So I'm going to take positive 3x to the left-hand side. It's going to become minus 3x is equal to, what number do I already have on the right-hand side? 7. So I'm just going to drop that 7 as 7. And do not forget, we had 5 that was on the left-hand side. We take it to the right-hand side, it's going to become minus 5. So 2x minus 3x is negative 1x is equal to 7 minus 5, which is 2, positive 2. And now I have not solved the equation yet because x is not alone. It's not 1x is equal to something. The coefficient of x is negative 1. And in order to get rid of this coefficient, remember it's negative 1 times x. There's an invisible or implied multiplication between the coefficient and the variable. So the opposite of multiplication is division. So to get rid of that, I'm going to divide both sides by negative 1. So negative 1 divided by negative 1. Remember, negative divided by negative is a positive. I'm left with positive 1x, or just simply x, is equal to 2 divided by negative 1, which is negative 2. And that is my final answer. Right, moving on from there, we also looked at algebraic equations that made use of the distributive property. Now, the distributive property basically states that whatever value or number that is outside of the brackets has to be multiplied to every term that is inside of the brackets. So, for example, if I have an example like this, negative a minus 1 is equal to 2 into 2 minus 3a, right? Now, if I look at the left-hand side of the equation, I can apply the distributive property. What number is in front of the brackets a minus 1? Now, we are so tempted to say that there's an invisible 1, but actually, there's an invisible negative 1. Do not forget about the sign. So negative 1 is being multiplied to the brackets. So it's negative 1 times a minus 1. So I'm going to take negative 1 and I'm going to distribute it to every term that is inside the brackets. I'm going to say negative 1 times 1a and negative 1 times negative 1. So negative 1 times a is negative 1a, and negative 1 times negative 1, a negative multiplied by negative is a positive, so it's plus 1. It's equal to, and on the right hand side, I'm going to distribute 2. So I have 2 multiplied by 2 and 2 multiplied by negative 3a. So 2 times 2 is 4, and 2 times negative 3a is negative 6a. And at this point here, I can take my variable a to the left-hand side of the equation and the numbers or the constant to the right-hand side of the equation. So negative 1a is perfectly fine on the left-hand side. I'm just going to drop it down as is. 1, positive 1 or plus 1, I need to take it to the right-hand side, so the sign is going to change. It's going to become minus 1. Now let's look at the right-hand side of the equation. 4 is perfectly fine on the right-hand side, so I drop 4 as 4. And remember, I took this 1 to the other side of the equation, it's minus 1. And negative 6a, I'm going to take it to the left-hand side of the equation, it's going to become plus or positive 6a. So I have negative 1a plus 6a, which is 5a, is equal to 4 minus 1, which is 3. I divide the left-hand side by 5, the right-hand side by 5. A is equal to 3 over 5. Now, you can substitute that in your calculator. Let's look at what the left-hand side is equal to. So it's negative 1. I'm going to substitute a in brackets. I'm going to substitute a in brackets for 3 over 5. And on the left-hand side, I have 2 over 5, and let's see what I have on the right hand side. So I'm going to substitute 3 over 5 in the place of a. So it's 2 into 2 minus 3 times 3 over 5, and that is also 2 over 5. So I know that my answer is correct. The left hand side of the equation is in fact equal to the right hand side of the equation, and you can practice the other questions that are there for you as well. Moving forward from there, we are also required to solve for x. So if we have an equation that involves a fraction, for example, if I have negative 3x over 3, it's equal to 3, and I'm required to solve for x. And of course, if I look at the right hand side of the equation, 3 is also a fraction. You might say, how can 3 be a fraction? It looks like a whole number. But I can also rewrite 3 as 3 over 1. Right? That's perfectly correct as well. So the first thing I need to do is clearly get rid of this denominator of 3. And I know that a fraction is the exact same thing as division. It's actually negative 3x divided by 3. So the opposite of division is multiplication. And to get rid of this divided by 3, I need to multiply both sides of the equation by 3. Or you can say 3 over 1. Now you might say, why am I multiplying the left-hand side and the right-hand side of the equation by 3 over 1? It's because I want to get rid of this 3, because 3 divided by 3 is 1. And in primary school, I'm sure they've used the word cancelled. They cancel each other. But actually, what we are doing is we're dividing off the numbers. 3 divided by 3 is 1. So what am I left with? I'm left with the numerator, which is negative 3x. It's equal to the right-hand side, which is 3 times 3, which is 9. And now I just solve the equation as any other equation. I divide the left hand side by negative 3. I divide the right hand side by negative 3 as well. So what am I left with? I'm left with x is equal to negative 3. And that is my final answer. And you can check to see if that is correct as well, right? You can also check to see if that's correct as well. Negative 3 times negative 3, that's positive 9. Positive 9 divided by 3 is 3. And on the right hand side, we started off with 3. So 3 is equal to 3. And that is my final solution from there. Also, in the test, I could test you on functions. Now remember, a function is very simple. It's like the analogy. If I have a car, right? If I have a car and the car is unwashed, so it's a very dirty car, what am I going to do is I'm going to take this car to the car wash. And from there, what's going to happen? I'm going to, the result, right? It's a nice clean car. So first I had a dirty car. I took it to the car wash and now I have a clean car. It's the input was the dirty car. The process, or what caused that change, in our context, it's the equation, and the output is a spotless, clean car, right? So let's think of that in functions, in terms of functions as well. Let's say I'm given the function y is equal to 2x minus 1, and I'm required to find the value of a and b from the table. So my first row is my x values. Let's say my x values are uh, -2, -1, 0, and there's some space here, and this is b. So according to this table, when x is equal to -2, the y value is a. That means I need to find it. A is basically question mark. I need to find what is this value of a. When x is equal to -1, y is equal to -3. When x is equal to 0, y is equal to -1. And when x is equal to b, y is equal to 199. Again, we need to find that value of b. So let's look at an example or a pair that's given to us. When x is equal to -1, we said y is equal to -3. But why is y equal to -3 when x is equal to -1? It's because we substituted -1 in the place of x. In a sense, the x values is our input values, and the y value is the clean car. It's the output values. So let's do that. I'm given the equation y is equal to 2x minus 1, right? Where I see x, I'm going to substitute -1 in the place of x. So what is the y value? It's 2 multiplied by -1 is a -2. -2 minus 1 is -3. So that is why when x is equal to -1, y is equal to -3. So how will we find the value of a? To find the value of a, I need to substitute -2 in the place of x in order to get this y value. So it's y is equal to x, 2x minus 1. That's the equation. I'm going to substitute -2 in the place of x. So it's 2 times -2, which is -4. -4 minus 1 is equal to -5. So a is equal, so instead of writing y here, I can just substitute a in the place of y because that's what we said is the variable in that place. So a is equal to -5. And when the y value is 199, we can use our inverse operations to find the b value. So let's see what I mean. I'm given the equation y is equal to 2x minus 1, right? I want to find this b value. So I'm going to substitute 199 in the place of y. It's equal to 2, and instead of writing 2x means 2 times x, I'm going to write 2b minus 1. And I can just solve this linear equation as any other linear equation. And remember, if m is equal to n, without swapping and taking numbers to the other side of the equation, I can just make the left-hand side the new right-hand side and the right-hand side the new left-hand side. I can rewrite this as n is equal to m. So this is 2b minus 1 is equal to 199. And I solve this equation as I would any other equation. I take -1 to the right-hand side of the equation. 2b is equal to 199 plus 1. 2b is equal to 200. I divide the left-hand side by 2, the right-hand side by 2. b is equal to 100. Right? And that is my final answer. And when I see this, I can see that 2 times 100 is 200, and 200 minus 1 is 199. Right? And the last part of your test will be tested on word problems. And remember, word problems, it's quite simple. You just need to know some terminology. For example, if I talk about the product, I mean it's the solution for multiplication. If I talk about the sum is the solution for addition. If I talk about difference refers to the solution for subtraction. And if I talk about the quotient is the solution for division. So these are terms that you should know by now. You should also know what doubled means. Double means times by 2, twice means times by 2, and so forth and so on. If I say triple, times by 3, and whatnot. And Moving on from there, let's look at an example that I gave you. It says Jimmy, and let me actually write it down so it makes more sense in the context. It says Jimmy is 3 times as old as Ben. So he's 3 times as old as Ben. The sum of their ages is 40. Find the ages of Jimmy and Ben respectively. Right, okay, so I just quickly wrote the problem. So step one with regards to solving word problems is read the question carefully. If you read it the first time, read it the second and third time as well. Look to see what is required of me. In this case, I'm required to find the ages of both Jimmy and Ben. Now, the second thing we do is we let a variable be, or an unknown variable be, x. So if I read this carefully, Jimmy is 3 times as old as Ben. Right? He's 3 times as old as Ben. 3 times means times 3. So what I'm going to do is I'm going to let Ben's age be x. I'm going to say let Ben's age be x. So Ben's age is x, right? Let's just get that right. Okay. Okay, perfect. So Ben's age is x. So if Ben's age is x, what is Jimmy's age? Jimmy's age is 3x because it's x times 3, which is 3x. 3x means 3 times x. Please do not write x plus 3. That's incorrect. It's 3x, 3 times x. Now, the sum of their ages, again, a very crucial word. Sum means addition. So if I take Jimmy's age and I add it to Ben's age, the sum, it is equal to 40. So we have Ben's age plus Jimmy's age is equal to 40. So Ben's age is, in terms of x, it's 1x. Remember we said it's x and there's an invisible coefficient of 1. That's by the x. Plus Jimmy's age, which is 3x, is equal to 40. So these two are like terms, 1x and 3x. Why are they like terms? They have the same variable and they have the same exponent. So 1x plus 3x is 4x is equal to 40. I divide the left-hand side by 4, the right-hand side by 4, x is equal to 10. So since this is a word problem, I can end it with a nice sentence as well. I can say Ben is 10 years old. And that's why it's important to tell me who is x. In this case, Ben is x and Ben is 10 years old. So it's important to write your final statement. But we are also required to find Jimmy's age, and I need to show the working out on how I find Jimmy's age. Jimmy's age is 3x. That means he's 3 times as old as Ben. And now we know what Ben's age is. It's 10. So I'm going to substitute, we said that x is equal to 10. I'm going to substitute 10 in the place of x. So it's going to be 3 into 10. It's equal to 30. So my final statement is, therefore, Jimmy is 30 years old. Right. So Jimmy is 30 years old. Right. Let me just position this camera so that you can see clearly. Right. Okay. But nevertheless, that basically sums up what you need to know for the test. And that is where we are at the moment. I wish you the best. Please continuously study and also go through the revision pack as well. Thank you.